Here is a mini lecture about colorings modulo 2. This one's quite simple. What we're going to see is that if we work modulo 2, then the question, can this link be colored mod 2, is extremely simple. So this is a complete exposition of proposition 2.11 from the notes. So here is the proposition itself. It's got two parts. First, every link with two components, whatever it is, as long as there's two components, then it can be colored modulo 2. And the second part is that no knots can be colored modulo 2. So the answer is simple. Can this thing be colored modulo 2? Yes, if it's got two components or more. No, if it's only got one component and so is a knot. So here's the proof. I'm going to show you the whole proof for the first time in one of these mini lectures. So the point is right here at the start. The coloring equation holds at this crossing here if and only if A is congruent to B mod 2. If and only if the two arcs which pass under the crossing have the same label. Why is that? Well, let me show you just down here. What does the coloring equation say? It says that A plus B should be congruent to 2C mod 2. Well, modulo 2, 2C is just 0. So that tells us that A is congruent to B, A plus B is congruent to 0 mod 2. Well, let me move B across. Let me subtract B from both sides to get that A is congruent to minus B modulo 2. Well, modulo 2 minus B, that's congruent to B. So we get that A is congruent to B mod 2. And each of these steps was reversible so that the coloring equation holds if and only if A and B are congruent. And let's just leave that alone down there in the corner. Now, back to the proof. The coloring equation holds at this crossing if and only if A is congruent to B mod 2. So consequently, the coloring equations all hold if and only if all the arcs in a given component have the same label. Why is that? Well, think about a single component of my link and think about what it looks like in the diagram. Well, what I can do is I can put my pen down on part of that component and travel around the diagram along that component until I get back to where I started. Well, at all times I'm traveling along an arc as I do that, or I pass underneath the crossing. So as I pass underneath the crossing, I move between different arcs which potentially have different labels, but actually, since the coloring equation holds, they have the same label. So to recap, the coloring equation holds at a given crossing if and only if the two understrands have the same label. So the coloring equations all hold if and only if all the arcs in a given component have the same label. So if the link is a knot, then there's only one component. So all the labels are equal. But then that's not a coloring, because in order to have a coloring, we need to have that the labels are not all congruent. I guess I should have written congruent. Let's edit that. Congruent. Whoops. Cong. Next. I should put a comma in there. Let's try again. There we go. Congruent, comma. Now, what's next? If the link has two or more components, then we can obtain a coloring very simply. All we do is we label one component with 1 and we label all the others with 0. Well, then this condition here still holds, so the coloring equations all hold. and the labels, they're not all congruent modulo 2, because some of the labels are 1 and the rest, and there are some of the rest because there's 2 or more components, the rest of the labels, they're 0. Okay, here's an example, just to show you how we colour modulo 2. So this is a link with 2 components. One of the components, let me show you the 2 components. Here's one of them. Right, and here's the other one. So there's 2 components. So I can make a colouring by choosing to colour one of the components, the orange component, with labels all 1, and the other one with labels all 0. So let's do that. So let's make all of these 1. There's one arc, and here's another arc. And let's make these all 0. 0, 0, 0, 0, 0. Is this a colouring? Let's pick a crossing and check. Let's try an orange crossing. Let's look at this one here. Well, what does the colouring equation say there? It says that we should have the sum of the 2 understrands, so that's 0 here plus 0 there, and that should be congruent to twice the label on the overstrand, which is 2 times 1. And is that true? Yes. And you could check every other crossing. For example, let's look at a green one here. Well, do you see that all the labels there are 0, so the colouring equation says that 0 plus 0 is congruent to 2 times 0, also true, and you can now check the rest. So here is the story of colourings modulo 2.